Assalamu alaikum. How are you students of standard 10? Hope you all are fine. Welcome back to my physics class. Dear students, I am taking chapter 9 from your physics book. So today I will explain lens. So today's class is about lens. Lens. From long ago, the Greek and the Arab knew how to use lenses as magnifying glasses. Nowadays, lens plays a very important role in our everyday life. Using lenses as spectacles, millions of people can read and write without trouble. Not only this, it has been possible to rectify several kinds of optical defects using lens. Had there been no camera, projector, microscope, or telescope, our way of life would have been thoroughly changed. And all these are made of lenses. Light is refracted through lenses, and as a result, images are formed. So, in this chapter, I will explain about different types of lens, formation of images with the help of ray diagram, etc. So lens, what is lens? At first you have to know. A lens is a portion of transparent medium bounded by two spherical surfaces or by a plane surface and a spherical surface. Lens is of two types, convex lens and concave lens. Dear students, here is the definition of lens. A lens is a transparent refractive medium bounded by two spherical surfaces. And you know, lens is of two types, convex lens or converging lens. The other name of convex lens is converging lens, and concave lens or diverging lens. That means diverging lens is the another name of concave lens. Okay, look here the picture of convex lens and concave lens. So let's know what is the definition of convex and concave lens. Sorry. Convex lens. The lens whose mid portion is thick but the edges are thin. Look here, the mid portion is thick but the edges, that means at the two end, is thin. That is called convex lens. As the convex lens can converge a beam of parallel light rays after refraction, hence it is also called converging lens. And concave lens. The lens whose mid portion is thin but the edges are thick is called concave lens. As the concave lens can diverge a beam of parallel light rays after refraction, hence it is also called diverging lens. That means the rays of light which incident on the convex lens after refraction converge to a point. That means রিফ্র্যাকশনের পরে আলোক রশ্মিগুলো কোন একটা বিন্দুতে মিলিত হয়। কনভার্জ মিন্স কোন একটা বিন্দুতে মিলিত হওয়া। অ্যান্ড ইন কেস অফ কনকেভ লেন্স আফটার রিফ্র্যাকশন রিফ্র্যাক্টেড রেগুলো কোন একটা বিন্দু থেকে ছড়িয়ে পড়ছে বলে মনে হয়। দ্যাটস ওয়াই ইট ইজ ডাইভার্জিং। সো convex lens is also known as converging lens and the concave lens is known as diverging lens. So dear student, here you have to memorize all the definition of convex, concave and lens. Look, there are other types of lens. Double convex, that means both side is convex. Plano convex, converging meniscus. Double concave, plano concave, diverging meniscus. Now, I will explain about different parts of the lens. Okay. So at first, center of curvature. Both surfaces of a lens are parts of different spheres. You know, lens is a portion of transparent medium bounded by two spherical surfaces. So both surfaces of a lens are parts of different spheres. Look here. This is one sphere and this is one sphere. So the both surface of the lens is the part of two different spheres. The center of each sphere is called the center of curvature of the respective surface. In the figure, look, C1 and C2 are two centers of curvature of the lens ln. Here ln is the lens, and for a lens there will be two centers of curvature. If one of the surface is plane instead of spherical, suppose if the lens is plano-convex or plano-concave, whose one surface is plane, then in that case, its center of curvature will be at infinity. Now, principal axis. Generally, there are two spherical surfaces of a lens. The straight line passing through the two centers of curvature of the two spherical surfaces is called the principal axis. Look in the figure, the straight line C1, C2. In this figure also, C1, C2 is the principal axis. That means the line joining the two centers of curvature is called principal axis. Look. Here the line that goes through the C1, C2, and in case of here in this figure also, C1, C2 is the principal axis. Now, optical center. The point on the principal axis inside a lens through which if a ray of light is passed, then due to refraction, if the ray emerges from the other surface, being parallel to the incident ray, then it is called optical center. Look in this figure, a ray of light PQ. PQ is the ray of light incident on a surface of the lens, incident at this surface. Okay. Then lens is formed by glass medium. So through glass medium it will be refracted. Look here, you know, light comes from rarer to denser, then it refracts. It bends, isn't it? You know, from refraction of light. So QR is the refracted ray and RS is the emerging ray. So look here, in this case, the incident ray and emergent ray will be parallel to each other. So here, in this figure, a ray of light PQ incidents on a surface of lens and refracts along the path QR. This ray emerges from the other surface along the path RS. The emergent ray RS and the incident ray PQ are parallel to each other, that I have told you. The refracted ray QR intersects the principal axis C1, C2 at the point O inside the lens, and that point O is called the optical center of the lens. So here O is the optical center. So look, again try to understand. The incident ray and emergent ray are parallel to each other, and the refracted ray that goes through the point on the principal axis at point O. So O is the optical center. Okay. Now, principal focus. When a beam of parallel rays adjacent to the principal axis, look here, principal axis, adjacent to the principal axis, is incident on a lens in a direction parallel to the principal axis. That means principal axis er dike jodi parallel beam of light incident hoy on the lens. Then after refraction, so while going through the lens, it will be refracted. Then after refraction, the refracted rays either actually converge to a point on the principal axis in case of convex lens, or they appear to diverge from a point on the principal axis in case of concave lens. Look, here these are the refracted ray. The rays of light parallel to the principal axis incident on the concave lens. Then this is refracted ray, and if we extend back the refracted ray, then all the refracted ray meet at a point F on the principal axis. So here the rays of light seems to be diverge from the point F. So in these two cases, this F and this F are the principal focus for the two lenses. Do you understand? Now, focal length. The distance of the principal focus from the optical center of a lens is called the focal length of the lens. Look, this distance will be calculated from the optical center. That means the distance between optical center and principal focus is the focal length, and that is denoted by F. In this figure, OF is the focal length of the lens. This is principal axis and focal point, that means principal focus, and the distance between principal focus and optical center is focal length. Now, focal plane. The imaginary plane at the principal focus perpendicular to the principal axis is called focal plane of the lens. In this figure, ABCD is the focal plane of the lens. Look, in the perpendicular direction of the principal axis, there will be considered an imaginary surface, imaginary plane that pass through the principal focus is known as focal plane. This plane is imaginary. Now, I will explain some rules for ray diagram in the lens. Rays of light incident in a direction through the optical center of a lens is refracted along the same direction. Look, for the convex and concave lens. Here it is convex lens and it is figure B, it is concave lens. So in both cases, if the rays of light incident in a direction through the optical center, then the refracted ray will go through the same direction along a straight line without any deviation. Okay. Number 2. Rays incident in a direction parallel to the principal axis. Okay. After refraction passes through the principal focus. In this case, and also in case of concave lens. This is refracted ray, and you know for concave lens the principal focus is virtual, and for convex lens principal focus is real, because here actually the rays converges to a point F, but here the refracted ray seems to be diverged from the point F, because this is refracted ray and it is extended back to this point. That's why it is a virtual principal focus. Rule number 3. A ray of light incident through the principal focus or directed towards the principal focus after refraction through the lens becomes parallel to the principal axis. That means if any light incident through the principal focus on the lens, then after refraction it will be parallel to the principal axis. That means this and this is totally opposite to each other. Here principal axis এর সাথে parallel হলে focus দিয়ে যাবে, আর focus দিয়ে গেলে principal axis এর সাথে parallel হবে. So you must remember all these 3 rules, because for drawing ray diagram you will require these rules. And in the next class I will show you how to draw ray diagram of for convex and concave lens, and that is very much important in this chapter. Dear students, now I will explain one thing. Identification of lens. How can we identify any lens is convex or convex? When we hold a finger in front and very near of a lens and then look from the other side, if a virtual, erect and magnified image of the finger is found to be formed, the lens is convex. But if the image is virtual, erect and diminished, the lens is concave one. You must remember. Okay, so it can come in your exam as 2 marks question. How can you identify any lens, whether it is convex or concave? So in that case, you can explain it in this way. Okay. So dear students, I have to finish my lecture today. In the next class, I will show you how to draw ray diagram. And I have told you already that is very much important for your SSC examination. Be your own reason to smile. Goodbye everybody.